Okay, so the last little part of this lesson, it's all about combining reflections. So it might be reflect over the x-axis, then reflect over the y-axis. Or reflect over the y-axis, then reflect over the x-axis. Or reflect over the x-axis, then reflect over the mirror line. Or reflect over the mirror line, y equals x, and then reflect over the y-axis. All those combinations. As long as you follow the order, you'll end up with the appropriate graph. I don't think we really need to go over how to draw these because it's just a bit redundant. But what I would like to point out is the notation. So for example, if we have y equals f of x as our original function, and we go to y equals negative f of negative x, that's basically implying we have a reflection in the x-axis and a reflection in the y-axis. Okay, if you were to look at this graph, this is what we're starting with. We reflected over the x-axis and then reflected over the y-axis, you would end up with this graph here. But what if you reflected over the y-axis first? So you reflected here and then reflected over the x-axis. Would you get the same graph? Yep. Okay, so if you reflected here first and then reflected over the x-axis, you would still end up here. So it doesn't matter if you reflect over the y-axis then the x-axis, or reflect over the x-axis then the y-axis. It's just important to know that this notation means reflecting over both the x-axis and y-axis. You're always looking at what is changing. Okay, well, y is being mapped to negative y, and x is being mapped to negative x, or replaced with those. So we're changing both the signs on the x and y coordinate. Okay, if you do want to go through all the transformations, these notes are on Moodle, but I feel like it's really redundant, so we won't do that. Okay, let's go to part 2 on the next page. Again, we're just going to talk about the notation. Okay, any guesses if we start with y equals f of x and we resulted with x equals f of negative y, what would happen? What kind of transformations? What's that, Robo? Okay, good. So the y is being affected, so that means we're reflecting over the x-axis. And what happened to the order? We started with y equals f of x, but now it's x equals basically f of y. So that means we took the inverse and we reflected over the x-axis. Okay, what about here? X and y are exchanged, so we took the inverse. And then if the negative's on the outside, I'm just going to rewrite this notation here. I can move that negative to the left-hand side. If x has gone, or if we've gone from x to negative x, the x-coordinate has changed, which means we've reflected over the y-axis. So if the x value changes, we reflect over the y-axis. And as well, the x and y have been interchanged, so we've taken the inverse. We reflected over the line y equals x. Okay, so there's just two transformations in this notation here. Inverse and reflection over the y-axis, and this is the inverse reflection over the x-axis. So we're just going to fast forward to lesson 4, and basically we're going to practice using those notations and review a little bit of the individual reflections. So just going down to example number 1, we're asked to write the equation of the image after reflection in specific lines. So if we started with y equals x squared, and we're reflecting in the line y equals x, that means that x is going to be replaced with y, and y is replaced with x. Okay, if we do that, then we get x equals y squared. And we should rewrite that so it's a y equals equation. And we get the positive negative square root of x equals y. Don't forget to take the positive and negative square root. Okay, we're reflecting in the y-axis. So everything is flipping from one side, say the left side to the right side, or the right side to the left. Okay, which coordinate will be affected? Is it the x or the y coordinate? We're reflecting over the y-axis. Good, the x values. So x is being replaced with negative x. So in that case, we end up with y is equal to 10 to the power of negative x. Stop there. Okay, for the next one, we have y equals the square root of x. There's going to be a reflection in the x-axis. So if we reflect over the x-axis, the y coordinates will change. So y will go to negative y. And if you want, you can start by replacing the y with negative y. And write negative y equals the square root of x. You could write it in that form, or more commonly, if we isolate the y, it would be y equals negative square root of x. How are you doing so far? The notation's okay? Best thing you can do is just test it out. If you're unsure which is going to be affected, whether you're putting a negative here or here, you could just graph it. Okay, start with y equals 10 to the power of x. And then you know you want to reflect it over the y-axis, so you could try it. Put y equals 10 to the power of negative x in your y2. If it reflects over the y-axis, you did a good job. So that's just a backup if you're unsure. Okay, and hopefully with practice you'll be able to just write it down right away. Okay, example number 2, we're going to describe basically what's happening to the first function. So if we started with y equals x cubed, now we have y equals negative x cubed. What's happening to it? Is it an inverse? No, x and y didn't change, but there is a negative there. So is it reflecting over the y-axis or the x-axis? Not x? Let's test it. Okay, if I replaced a negative x for my x, I would get y equals negative x cubed. When I expand that, I get negative x cubed. Okay, so reflection over the y-axis. That one worked. Let's try the x-axis. Okay, so if y is replaced with negative y, then we would write negative y equals x cubed, divide by the negative, and do we still get y equals negative x cubed? Yep. So in other words, for part A, it could be either a reflection in the y-axis or it could be a reflection in the x-axis. It's both. Not at the same time, but it could be one or the other. Okay, so if you do have room, you might just want to say it's a reflection in the y-axis or a reflection in the x-axis. One or the other. Okay, hopefully part B we can see that the x and the y have been interchanged, which means that we have a reflection in the line y equals x. Closer to the end of the semester, we're going to look at some trigonometric functions, so the graph of sinusoidal functions, graph of cosine functions. In this case, that's not too important. We're going from y equals sine x to y equals sine negative x. So if x is being replaced with a negative x, what are we reflecting over? Y-axis, good. So if you can think about which coordinates are changing, the x or the y, I think that's really going to help you with figuring out what you're reflecting across. Okay, so again, the thin line is going to represent the original function, and the thick line is the graph after the transformation. So we've got to figure out what would be the equation after the reflection. We're starting with y equals x squared in this case. So the parabola is our original graph. Has it been reflected over the x-axis? Okay, if it had been reflected over the x-axis, you would get something like this. But we don't have that. If it was reflected over the y-axis, this is completely symmetrical about the y-axis, you'd get the same parabola. So it's neither of those. This is a reflection in the line y equals x. So if we started with y equals x squared, then our resulting equation would be x equals y squared. Solve for y, we get the positive negative square root of x. So who remembers how to tell if we have a function or not? Okay, because they're also asking us, does the reflected graph represent a function? Okay, I'm getting some answers, but how do we determine? Vertical line? Yeah, good.
If there's more than one x value, it's the same.
Then it's not a function. Good. So if we were to draw a vertical line through this transformed function, well, it's not a function, this transformed relation, we would get an intersection at 2 points, which means that x repeats. So if x repeats, it's not a function. Jared, over here, which line are we reflecting over? Good. Okay, so we're reflecting over the x-axis. So if we started with the equation y is the absolute value of x, then our reflected image over the x-axis would change all the y-coordinates. So we could write it as negative y equals the absolute value of x, because y is being replaced with negative y. Or you could write it as y is equal to negative absolute value of x. You will most commonly see it where y is isolated. Okay, do we have a function for the bold graph? Do any x coordinates repeat? If you were to do a vertical line test, it only intersects at one point, which means this is a function.